Alright G, in today's tutorial we're going to go draw things on a custom view. I call it a canvas. I was doing this in a classroom recently and my students actually wanted it in the shape of a video, so we'll make this video in Android Studio with basic Java development. We will draw custom things on a view. No widgets, no buttons, no image view, no layouts. It's going to be a plain canvas, and with the pixels we're going to draw basic shapes like rectangles and circles. And not only we're going to draw them, we're going to set their colors and we're going to try to animate them as well. So this is the idea. Let's say this is my phone screen. I'm going to go set the whole screen as a white background. Also, I'm going to draw a few basic shapes. For example, I'll draw a circle here. I'll draw a rectangle here. I'll probably draw some text here. And I could probably go for drawing a few more items here. So you can already see that this circle can be used as a ball, and then we're going to animate this ball to go bounce off the on the tab on this rectangle, and it is going to bounce back from the right wall and the left wall and the top ceiling as well. And if the ball goes below this, the game is over. Oh, we're making a bouncing ball game already. Let's see how far we can go with this, but this is going to be a basic Android Studio project with Java. So let's go down to Android Studio and make a project. All right, so I'm making a new empty activity project here, and let's call it my bouncing ball 1. Let's wait for the project to be in the initial shape. As you know, when you create an empty project in Android Studio, it's going to make two files for us. One is the layout file for the main activity, and the other is a Java file that I have here. So this Java file will remain as is, but this main activity file, I don't need it. So I don't need the layout. So I can close this file. All I need is this main activity file, and in this main activity file I also don't want to set the content, so I'm going to delete this line, set content view. Rather, I will create a new Java file in the project. Here you can see this is my package. Right click, new class file, and I'll call it my canvas. So this is my my view or my canvas. This is my class, and it will extend a view. So once it is extending a view, you have to create the constructor. It creates it for you. Also, you have to override on draw function, so it does it for you as well. So these are the two functions that we need. That said, my canvas is available, and I can go back to my activity and I can create my canvas. C is equal to new my canvas, get application context, and we are ready with the canvas. And instead of setting the content to my XML file, I will say set content to C, and this should actually set my screen to the canvas. Just to make sure that this canvas is being set on the screen, I will go back to onDraw function, and I will say canvas dot draw color, and I will set color to, let's say, something more sharp and clear so that I know that this has worked. Let's set it to red. So when I set it to red, the whole screen is expected to go red. Draw circle, not draw circle, come on, dot draw color, color dot red. Okay, so now when I set it to the right emulator and try to run this, my expectation is that when the application starts, it's going to start with a view, and that view is not my usual resource layouts and activity main.xml. I am not using this XML file anymore. Once my emulator starts, it will actually pick my canvas and put a red color on the whole screen. Why on the whole screen? Because for the whole activity, I have set content to this canvas. So my phone is starting. Yeah, I have a different language here. So the application starts, and here we go. So it is the red color. I don't want the red color in the background for forever, so I will change the background to white, And now let's see how I can draw other things. For example, I can have a few paints. So let's say let's draw a blue ball and a red rectangle. So I can have a paint red is equal to new paint red import the class red dot set color to color dot red. Similarly, I have another paint, let's say blue, blue dot set color to color dot blue. Why am I creating these new paints? I will use these paints to, for example, canvas dot draw circle for center, let's say 100, 150, and the paint is red. So now my background is white and my circle that I'm drawing at 100x, 100y. So this screen will have somewhere over here 100 pixels, and for 50 radius I will draw a red ball. Similarly, I can go for draw rectangle, and I can do this with left is going to be, let's say 300, top is going to be, let's make it 100, 300, right is going to be, let's say, I don't know, 300 plus 100, 400. So 100 plus 100 is 200, and the bottom is 300 plus 350 SA, and the paint for this one is going to be blue. So it's going to be a blue slab or a blue box. So I'm starting on the left side at 100 pixels from here, 300 pixels, so somewhere over here, and the right side is 100 plus 100, so this is going to be rectangle 100 wide, and the height is going to be 50, so it's going to be a rectangle which is more wider than taller. So let's run this and see how this new screen comes up. Background should be white, and this is at 100, 150, and this is at 100, 300. Yes, the top left of this slab is 100, 300. So I can see that my width for this box should be something like 3 times of current. So my current is 100, so let's make it 300 plus 100 is going to be 400. Height is fine, and this is how it's going to go. Now I want to bring this slab down here. Also, for the canvas, I can get the width and height. So I can have let's say integer width is equal to canvas dot get width, and integer height is equal to canvas dot get height, and I can set things on the basis of this from here on. So for example, I can go for the initial position of this slab. Instead of top to be 300, I will say, man, make it the height of the screen minus 200. So the slab will be somewhere down here when I run this. Ooh, something went, oh, so the top is 200. I did not change the right, and the bottom should be height minus 200 plus 50. Then this is going to work. Yeah, okay. So now I want to animate this ball, and I want to animate this slab, and I want to put some limitations. So there are a few things I need. For example, the variables that I need is what is the XY position of this ball, what is the width and height of this ball, what is the XY position of this tab, and what is the height and width of this tab. So I can have these variables over here. I can say integer ball X, ball Y, ball width, ball height, and I can say int tab X, tab Y, tab width, tab height. And in the constructor, I can actually put the same numbers. The numbers were 100, 100 for ball X is equal to ball Y is equal to 100, and ball width is equal to, so if the radius is 50, I'll say the ball width is 100, ball height is 100. I don't know if I'm going to use this ball height or not, but now instead of X, Y, 100, 100, I will say this is ball X, this is ball Y, this is ball width by 2, and this red remains red. Why am I using these variables? Because I will soon start changing these variables every now and then to make this ball animate. Similarly, I will say I have variables like tab x is equal to 100, tab y is equal to 100. Later on I'm going to change this, and tab width is equal to, let's say, 400, and tab height is equal to 50. So I will say tab x here, tab y here, tab width here, and all this thing is tab height, which is yeah, looks good. So when I start this, tab is going to come on top of this ball. Yeah, so the size of the thing looks fine. Now when the canvas is loaded, I will bring this to a certain position, which is going to be after getting this width. I can always say that the tab y is going to be height minus 200, let's say, and this is going to bring the tab down here somewhere. Ooh, come on. So this is tab height. So यहाँ पे I have to, here we have to do this. Tab height is 50. So this is not height. This is actually the variable which tells you where is the bottom of the thing. So this is x. This is y. This is where the right end finishes. So this will be tab x plus tab width, and this is going to be tab y plus tab height. So this is the starting point of x. This is the ending point of this box. This is the starting top of the box, and this is the ending top, ending bottom of the box. So once we do these changes, we have a tab here, 400 width, and we can also draw some text here. Let's try that. Canvas dot draw string. What was this? Draw text. Yeah. X, Y, and paint. So I can say do this again at like 50, 50, and paint is going to be red, let's say. We'll change this later on maybe. And the text is hello. So this should print hello on the screen somewhere at 50, 50. Right here somewhere on the ball. It's too small for right now. So let's change the font size somehow. For that, we're going to change the paint text size. So for text, I can have another paint. Text paint is equal to new paint. I will send text paint dot set color to, let's say, color dot green, red, blue. Let's go for cyan. Text paint dot set text size to, let's say, 50. I hope this is going to be sufficient, and let's use this paint instead of red for saying hello. So once I run this, it should get me a cyan hello on top of this text, and this is sufficient. I can probably change this 50 to 70 or 80 as well. Now the next task I'm going to have is, oh no, S here. The next thing I want to do is I want to animate this ball. And for that, for every now and then, I will change XY position of this ball, and that will happen several times a second. Actually, the whole canvas will redraw several times a second. And for a usual cinema video, we know that the refresh rate is 24 frames per second. If I want to draw 24 frames per second, I can divide 1000 milliseconds divided by 24. So I should refresh around 42 times a second. This is what I'm going to do now. I go to my main activity. I create a thread. I create a new runnable. like that. And in this run, I will have a while true forever and sleep this thread for 42 milliseconds. Thread.sleep for 42 milliseconds. Put this in the try catch, and every 42 milliseconds you go and redraw my canvas. The canvas is C. To redraw the canvas, we say c.invalidate. So now my canvas is being refreshed every 42 milliseconds. But when I run this application again, it will not show any animations because, yeah, it is refreshing every 24 times in a second, or it is refreshing every 42 milliseconds, but this is not changing anything in the X and Y of the ball. So let's try. Before we refresh, we change the ball X and ball Y. Ball X and ball Y are in this class, my canvas. As they are default, they should be accessible here. So I'm going to say c.ballx++ and c.bally++. So we're changing the X and Y of the ball. Let's see if it's going to move the ball. So the application runs, and no, it's not making any changes. Ball X, ball Y. What is going on? Invalid. Oh, we did create the thread, but we did not start it. So we should do t.start. And if the thread will start, this should definitely move the ball. Oh yeah, you can see that slowly the ball is moving 1 pixel at a time. It's a little too slow. It should be 4 or 5 pixels at a time. So instead of saying change it by 1 pixel, I should have another variable, how much the ball should move when we ask it to move. So what is the change in X and what is the change in Y? I'll have two more variables for the ball. I will call them ball delta X and ball delta Y. And later on, I will use the same, need similar variables here. What is ball delta X, ball delta Y? We just figured that it should be like 4 or 5. So I can just initialize here. B delta X is equal to 4. And B delta X is equal to, delta Y is equal to 4 as well. Let's make it 5 for both. And instead of changing it by 1 here, I will say C is equal to C dot ball X plus C dot ball delta X. Similarly, instead of saying plus plus, C dot ball Y plus C dot B delta Y. So it changes by delta X, changes by delta Y, and when I run this, it's just going to go faster this time. So let's run it again and see how the ball goes from here. It's going faster. We can change this delta from 5 to 10 to make the ball faster, but the problem now is that this ball is going to go outside the window. All right, for that, we can try checking if it is going beyond the screen's width. So we will only increase the delta, increase the X if the current X position is within the screen. So if ball X is less than C dot get width, I hope this is going to work. So C dot ball X, then you will do this. And if C dot ball Y is less than C dot get height, then you will do this. So now it should actually stop it when you're trying to go outside the window, but we're checking the width of the screen, which should be, let's say, N, and when your ball X position has reached here, it will hardly be visible to you. So we have to subtract the width of the ball. So if the ball X minus C dot ball width is less than the screen width, then you will do the increment. Similarly, if the C ball Y minus C dot ball height, then you should do this. Let's see if the ball stops here from moving away. So ball is moving right, and ball is moving down, down. It should stop going right when it is going beyond the width of the screen, and it goes out. Ouch. Okay, what's happening here is that we're getting a different width here. To get the correct width, to get the correct width, we need to get this width, which was the canvas width, and we can make these variables here and initialize them in this case. So hopefully after a refresh, these numbers will change, and now we will be using these width, c.width and c.height instead of c.getWidth and c.getHeight. So width variable and height variable. Let's see if that works. Sorry. Okay, so x is increasing, x is increasing, x is increasing. It reaches. No, it's not working. C dot ball x plus minus c dot ball width is less than c dot width. I think it should be x plus here and y plus here, and let's see if that works, because I was going beyond the limit of the screen. So ball x plus 100, which is the ball width, it should stop now. So it's actually moving. It's not moving it to the right because this limit has been implemented with a gap. Let's fix the gap in a while as well. And it stops moving to the bottom as well. So why there is a gap on the right and gap at the bottom? Because I'm considering ball width, but this ball is basically being drawn with this reference to the center of the ball. So we should consider the radius, which is ball width by 2 and ball height by 2. So now when I run this, the ball will move and it should stop moving outside the right limit and continue to move down till it reaches the bottom. Stops on the right edge, very nice, and stops on the bottom probably. Yeah, so we really don't want to do that. If we are working on this, we are not trying to stop it from moving outside, but actually once it reaches this condition, so we're moving forward. If you are your x position is less than width, you keep moving forward. But if you go slightly above that, then you actually change the delta from whatever it is to a negative number. So you multiply it by -1 maybe. Yeah. So we want to check if you are going less than the width, then you obviously continue to increase the delta. Else, can we change this c dot b delta x and multiply it with -1? So let's see if we do this. This means that your stop. So what you need to do is, regardless of this fact, you continue to increase x. So you're increasing x. If this thing goes above the width, then you change the delta to minus whatever it is. Let's see if that works. So this should continue to increase the x. Oh, it is going the other way around. Why? C dot ball x plus C dot ball delta is C dot ball x plus ball width divided by 2 is greater than. So now we have to apply a limit for the left as well. So if the same thing happens, that your ball x is less than 0, which is the left of the screen, you do the same thing again. So if your ball is going out of the left limit, it should change the delta again. So let's run and see what happens to the ball. It is going right. Let's see if this limit is reached. When you reach this limit, it should change the delta to negative, whatever it was. And now it is going left. Hope it hits the bottom now and starts moving right again. So now, what do we need to do when you go at the bottom? We really want to let it go. We just don't want to apply this limit for now, because if the ball goes at the bottom, the game is over. For now, I can allow going all the way to the bottom, and if your ball height goes greater than the height, you can apply c dot b delta y, which is the change in y, multiplied by -1. In this way, your ball will go hit the bottom and start coming back up, hopefully. Let's see if this is going to come back up. Oh, this delta is slow. Let's increase the delta to, instead of 5 to let's say 10. So you can see the ball goes to the bottom and it bounces back again. Let's run again and see. So bottom, right and left bounce has been implemented. The top bounce has not been implemented. How to implement the top bounce somehow? To implement the top bounce, you could have a similar condition. So if your ball y is getting less than 0, then you could do the same multiplied by -1. Let's see how it goes. So now the ball is going to the right and bottom, hits the right wall, comes back, hits the left wall, comes back, hits the bottom, bounces up, hits the right wall again, bounce back. Let's see if it bounces back from the top as well. It goes up a little too much, but it works. So if the ball y plus ball height not divided by 2, yeah, so this should allow us to come back. Now let's move this tab to the right and left, and also try to implement the game over. So if my ball has gone beyond the bottom, this check needs to be removed. And if that is happening, in my canvas I will probably have a boolean game over is equal to false. I can set it in the constructor to false as well, so the game is not over by default. Here we can actually put if game over is equal to true. I can do a canvas.drawString. Instead of this, I can say, hey, game over, and put it at, let's say, x50 and y250. Okay, let's see if the ball goes beyond the bottom of the screen. And does it say game over? So hello is not being printed here. I'm expecting a game over here if the ball goes at the bottom. Oh, it starts bouncing back. What's going on? I did not delete this check. Yeah, this needs to be commented. So I commented this check. Now the ball should actually go beyond the bottom of the screen. Going, bounces back right from the right wall well, goes down, and it goes down, but does not say game over because we did not change this game over to true. For that, we have to check if the ball has gone greater than height. Yeah, if the ball of y has gone greater than height, change c dot game over to true. And once the game over is true, the thread should probably stop as well. But yeah, oh, it's game over already. If the c dot ball y is greater than c dot height, yeah, it goes down, but it is causing some trouble here. Maybe okay, let's see. So if it is not outside the screen, it should not be. That's working for now. Let's see if the ball goes below this bottom line and we get to see game over. Yeah, we get to see game over. Okay, now we want to detect the collision if the ball is colliding with the tab, and that can be done if the ball no. Yeah, for that we need this whiteboard. So we need to check if my let's say this ball and this tab are in this position, the left or the X of the tab and the X of the ball. So this center is the reference point for the ball, and this left edge and the top edge are the reference points for the tab. So if your center is on top of this tab, so how do we check if the center is on top of this tab? You check that the reference point is going to be above y of this tab. So tab y is more and the ball y is less. Similarly, the ball x is going to be greater than the tab x. So it is somewhere on the top and on the right. Also, if you want to make sure that the ball is not here, but it is in this limit, you can check if the ball x is less than the tab x plus tab width, and that is going to give us the range that the ball is here somewhere, or here somewhere, or here somewhere. Then we need to check it has to be above the tab. So for that, let's try to apply a check. We will put the check here again. So if my ball x, so my ball y has to be less than my c dot tab y. So the ball is above the tab. That's the first thing I'm checking. If it is above the tab, now we can check if my ball x is greater than c dot tab x and c dot ball x is less than these two things, which is c dot tab x plus c dot tab width. Hopefully this check will make sure that my ball is in the range. So this check will put the ball here somewhere in this range, and if my ball is hitting the tab, this is actually turning out to be wrong. For that we have to check if my c dot ball y plus radius, which is 50, c dot ball height divided by 2 is greater than or equal to c dot tab y, and it is not going below. So my c dot ball y minus c dot ball height by 2, so this is the top left corner, is less than c dot tab y plus c dot tab height. Yeah, so if that is the case, we have a collision. I don't know if I make sense, but once the collision happens, we need to bounce the ball up. The ball is bouncing up with this code, that is multiplying delta y to -1. Let's see if that happens. Is that going to land on the tab without moving the tab? Ta-da! Okay, so if it hits the tab, it's going to bounce the ball back. Now, how do we move the tab right and left? I could use the keyboard or I could use the accelerometer. And for now, it is bouncing all well. All I need to do is probably use another tab. So instead of having a tab here, I will have a few bricks here. So I can create one brick. If the ball hits the brick, it is going to missed. Very nice, game over. So if it hits the brick, it should make the brick disappear. So for that, I will have more variables. I will have integer brick x, brick y, brick width, brick height, and probably a brick color here as well. So I will have a new paint, brick paint. Let's change the color of the brick. Set color to, let's say, color dot green, red, dark gray, magenta. Yeah, magenta sounds good. And the way we created the tab here. I'll just copy paste this here. So this is not going to be tab X, it's going to be brick X, brick Y, brick X plus brick width, and brick Y plus brick height, and this is going to be brick paint. So my brick X, brick Y can be initialized here. We did not initialize it yet. So brick X is equal to, let's make it, how did the ball start? Ball started 100, 100. Let's make it like 600. BRY is equal to 600. Also the brick width should be less than the tab, let's say 200, and brick height could be slightly more than the tab height, which is like 50, 70, 100. Okay, 100. And let's see if that's gonna draw something for us. So when I run, so please note that the brick is not going to move, so we're not going to do anything about it. So it's going to, and if the ball hits it, it's going to go through it. So the ball is just going fine. For now, we cannot do much about it, but wait for the ball to hit the magenta. It goes hits the magenta, but does not do anything. Rather, it goes through and goes. So what do we need to do about this now is have a similar, what was that? Have a similar check for the break the way we had here. So this was all for the ball colliding with the tab. I will do a ball colliding with the brick Y. So ball height Y, ball Y. So this was brick Y, and this was brick Y plus brick height. So this is ball X, brick X, and C dot ball X, C dot brick X plus brick width. So we don't want to change the delta. We actually want to hide the brick. So for that, I have only one brick. I can have more such booleans, but for this brick for now, tab brick, this brick for now, I will have boolean show brick 1 is equal to true. What is show brick 1? We will draw it only if show brick 1 is equal to true. तो फिर आप ये draw करेंगे, वरना आप ये draw ही नहीं करेंगे. इस show brick 1 को हम false कब करेंगे? जब ये collision होगा. कौन सा collision था जी? यही वाला था brick वाला. So हम कहेंगे कि जी c dot show brick 1 is equal to false. Once that happens, it should stop showing the brick. Let's see how the game behaves. Now the ball is going around. Is it gonna hit the tab? Yes. It's gonna bounce back. Is it gonna hit the magenta brick now? Yes, it's heading there, it's heading there, and it destroys the pink brick as well. So now we have a working prototype of a bouncing ball game. It is bouncing off the walls as well. Now we really need to figure out we can also have a score. I mean, if this is changing, we can change the score. For example, I can have, let's say, integer score is equal to 0, and when I hit, before it stops showing, I should change this c dot score, add it 10 numbers for every hit. This is 10 marks, and I can do things like this draw text could have a score forever. This can have another, instead of 50 250, I will make it 50 100, and I will print score is equal to score. So now, as soon as the game starts, we should have a score equal to 0. And once we hit it, score is 140. Why did it go to 140? This means that it actually, I don't know, it actually refreshed 14 times before disappearing. Yeah. So for that we need to check, once you're increasing the score, if c.show brick 1 is equal to true, then only then you increase the score. Otherwise it was increasing the score for the invisible brick as well. So now when we run this, it goes nuts. Let's run this again. So it hits the brick, changes the score to 10, and we are through. I intentionally put the brick in the middle so that it comes in the path in the first go. Now I can have the initial position of the brick changed to something else. Let's say instead of 700, I can change it x to, let's say, 100 600, and probably it is not going to be in the initial path of the brick. Last thing we need to do is move this tab with an accelerometer that we have done already in some code in my class, but here in my main activity all I need is a sensor manager. Get system service, sensor service, sensor manager. So this is my sensor manager, and then I'm gonna get the accelerometer here. Dot get default sensors, sensor dot accelerometer. This is my, and then I can do, what was that, sm.register listener. We have sensor element listener and sensor. So this is the listener I have. Second thing I need to pass is this ACCL, and the third thing was accuracy sensor dot what was that, real-time sensitivity. So it was sensor manager dot delay, sensor delay normal fast gain should be gain for a real-time thing. Hopefully this should work. So whenever the sensor changes, we have sensor event dot values coming in into an integer array values. All we are interested in is float array v x y z. So all we're interested in is the 0th element. This is going to be my value x. Now if my this v0 is less than 0, I will change my c dot tab delta tab x. Do we have a tab delta? We should have one. We don't have this here, so we should have a, the way we have the ball delta, we should have a tab delta x and tab delta y. So delta y is always 0, tab delta x, we can initialize them. Tab delta x is equal to 0, tab delta y is equal to 0. So tab delta x should be minus 10, else this thing should be plus 10. This tab delta x is not being used, is it? So in this thread, I am using the delta x for the ball and delta x over here. Yeah, so we're increasing this. We should also do c dot tab x is equal to c dot tab x plus c dot tab delta x. So now once we change the accelerometer values, we should have a different behavior. Oh, it's already going up because the delta is being increased if it is not 0. So that's a slight bit of a mistake in my canvas. No, it's in the activity. So if it is less than 0, if v0 is greater than 0, else it should be 0. Also, there should be a limit. We have to apply the limit. We don't want the tab to just move out. So if I rotate my device, it's going this way. If I rotate my device otherwise, it is going the other way, but it is going the wrong way. So we should fix this code here. Again, the activity, it should be positive 10 here, negative 10 here, and in my thread here, I have to make sure if, no, not in the thread, it should be in the accelerometer. So I need to make these changes if and only if. So if we're changing it to minus 10, so if my c dot tab delta x is greater than 10, then we will do this. If my c dot tab delta x plus c dot tab delta tab width is greater than c dot width, which is the canvas width. If it is less than canvas width, only then we will increase x. So is that going to work? What happens in the else part? Hang on. So if I tilt this device, it's not moving. Yeah, so it's going down, but it is not stopping. So this delta is increasing. Let me hang on. Yeah, we'll come back. Okay. So if my delta is increasing, which is fine, if my tab delta x plus tab width is less than canvas dot width, then you do this. Else you set this to 0. There should not be an else here because, hang on, what's going on? This whole thing is in this bracket. So if my v0 is greater than 0, which is like we're going to the, yeah, positive. So if we're changing it to minus 10, before we change it to minus 10, we're checking if it is tab delta x has gone. If it is greater than 10, then we will do this. Else we change it to 0. And this should also not be an else. This should be an if again. So if v0 is equal to 0, we can also have a limit. So if it is greater than 2, which is less than 2, it is greater than 2, and if it is less, so you can see the accelerometer goes from 0 to 10. So if it is greater than 2, you're tilting it a little hard. So if it is less than 2, then you keep it 0. Oh yeah, let's see what happens now. So if it is not moving, if I turn it right or if I turn it left, nah, sad, this is not moving. This should be checking on, Yeah, not greater than 10. Come on, this has to be, if the tab x is greater than 10, then you change the delta. If the tab v0 is less than 2, if this is also tab x is greater than tab width, then change the delta. Yeah, let's try this again. So if I tilt this way, it goes this way. If I tilt that way, it should go the other way. Hang on. Which way is going fine? So when I run this and tilt the screen to the right, it's not moving. To the left, it is fine. So minus wala is working fine. Plus 10 is not working fine. So if v0 is -2, which is negative, you check if the tab x, yeah, plus tab width is less than width. Yeah, you go for 10. Yeah, this should work. Stop. If it is greater than 2, it should be less than -2 probably. Yeah, so let's run this again. On the right tilt, on the left tilt, it's working fine. On the right tilt, if it is less than -2, if it is less than -2, if it is greater than 2, if it is less than, so it should be between -2 and 2. So if it is less than 2 and v0 is greater than -2, then it should turn it to 0, because it is going other way and then turning it to 0. So if your v0 is less than 2, yeah, let's see now how it works. So on the left tilt it goes here, on the right tilt it goes here. Bounce. Oh, good stuff. So it looks weird on the emulator, but when you do this on device, this is going to be a lot of fun. And it hits and gets 10 marks as well. So I need to do a little movement. Yeah, you see, I can just move it on the tilt and it stops to the limit as well. So in this way I am successfully able to move it using the accelerometer. The ball is dependent on only the path we have given it, but the tab is moving on an accelerometer and the brick was not moving at all. So this was one quick tutorial on how to make a bouncing ball using a canvas. Just draw a circle, draw a rectangle and a drawstring with a number of paint things. Oh, it's gonna go down. Yeah, you see. Challenge. That's all for the video. I'll be uploading this and you should be able to access that soon.